question has been given some students some problems, so I'm going to help with it. So we have a table here, 1.14 table, shows the atmospheric concentration of carbon dioxide recorded at this Mauna Loa Observatory in Hawaii for selected years between 1960 and 2015. All right, so the first thing asks us to produce a scatter plot of CO2 concentration Y as a function of years since 1950. This is going to really help us because we don't want to enter in X values of 1960, 1970. We want years since 1950. So our X values are going to be 10, 20, 30, 40, 50, 55, 60, 65. And then our Y values will be here. So let's see how we can do this on Desmos. So if you go to plus and you can hit table, that's what I did first. And I went ahead and entered in this data table. And at first I did not see the scatter plot because I have to go over to this little wrench and I have to change my scale to show these values. So I went from -10 to 80. If I wanted to my steps are automatically 10. If I wanted to change the steps, like I wanted them to be 5, you can see I can change the step. That's going to change how frequently, but I think 10 is absolutely okay for this data set. And then my Y data set, I just made it go -100 to 500, and you can see the steps are by hundreds. You could change the steps to be by 25, it doesn't really matter. So let's just leave them by 100. All right, so now the question then asks us, oops, wrong screen. The question asks us, does it seem linear or quadratic? And it's kind of hard to tell because although it's not too far off a line, it does seem like maybe it's bending this way. And I'm going to show you how you can find out what's better, linear or quadratic. So it kind of looks like it could be either. So when we go here and we want Desmos to take this data and fit it into the model, we need to use Y1 because we want our Y1 data. Do you see how the Y1 data, it's automatically bringing that in. And then if you look on your keyboard next to your number 1, there's a squiggly line. And so if you hit Shift and that squiggly line, you're going to get this. And this is saying we want to make a regression equation. We want Desmos to take the data and make it fit best. Now, if it was linear, we would have mx1, right? Take that x1 data plus some y-intercept, right? And it made a line. And it doesn't look too bad. And it tells us that r is 0.9925, so it's really pretty good. All right, the closer r is to 1, the better the data fits that model. So let's try and see, does a quadratic fit better? So y1, little squiggly line. Now we want to use some letters here. So we're going to use ax squared. Oops, we need to put the 1 in there because we want that data. Now plus bx, because that's a quadratic, plus c. Right, so now we have, and we need to put the 1 there again. And we see 0.9996. So, right? Sorry, this r squared, we want to look at r squared, sorry. R squared is 0.985, and r squared down here is 0.9996. So this model is slightly better than that model. Right, so we have the quadratic model is better. All right, so let's go back to the question. It says judging, so it's very hard to tell from the scatter plot, but we went ahead and used the linear regression. Right? And we did that. So we found the 2 regression models. And how can we use those, right? So based on the model, what will the level be in 2025? So let's go here, right? We decided that this one is better, so we're going to get rid of that one. And what does this mean here? This means that we have y equals, here's our value of a, 0.012618 if we want to go in there. You could probably get okay with rounding it, right? That's a super crazy accurate decimal. But x squared, all right, and then we have that plus 0.577465x plus 309.899. All right, and that overlaps, right? We see those 2 colors. And we can play around with this a little bit. If I rounded this by like quite a bit, right, we're going to see, I'm just rounding it to 3 or 4. This would be, oops, I need a point 0.5775x plus, I'm keeping in that 4 decimal points, right? 899. And it's not going to be any different. And you could even play around with getting less decimals. But so we have our model from this data. And then what did it ask us to do? It said, based on what would the level be in 2025? So we have to think, all right, 2025 is an X value, and years since 1950, so 2025 would be 75. And I can come here, and in 75 years after 1950, what's my level? It's going to be 424.065. All right, so that is, oops, I keep going to the wrong screen. All right, what circumstances might cause this prediction to be off? Well, that might be that's too far away and something changes, right? Anytime we have a data set, right, it's called extrapolation. Anytime we're extrapolating what happens after the data set finishes, we like to think that past behavior is the best predictor of future behavior, or the past predicts the future. But anytime something changes, right, so something could change between 2015 and 2025, and that would make our model inaccurate. So I hope that helps you with this problem.